Today is day 3 of our logic lesson. We're going to talk about deductive reasoning today as well as Venn diagrams. To review, we want to remember what is inductive reasoning and why can't we use inductive reasoning to prove conjectures. Remember that inductive reasoning is an observation based on a pattern. You create a rule based on the observed pattern. We can't always use it because unless you can observe everything, you don't know if the conjecture is true. You can use a counterexample to figure out if it's true or false, or at least that it's false. For example, your coach has told you that if you miss more than one practice during the week, you will not be allowed to play on Saturday. You missed practice yesterday and today. What do you think will happen? Using inductive reasoning, we can conclude that we will not be allowed to play on Saturday. Deductive reasoning uses facts, definitions, accepted properties, and the laws of logic to form a logical argument. How is that different from inductive reasoning? You can look at our flow chart. We make observations. We make a bunch of observations. Therefore, we have a conclusion. In deductive reasoning, there's a rule or a law or a definition that leads us to the conclusion. The first law that we're going to look at is the law of detachment. If the hypothesis of a conditional statement is true, then the conclusion is true. So we have P, then Q. If P is true, then Q is true. Mary goes to the movies every Friday and Saturday. Today is Friday. It says convert to a conditional statement. A conditional statement, remember, is an if-then form. If it is Friday or Saturday, and it should say then, Mary goes to the movies. I'm going to add the word then in there. Our hypothesis is it is Friday or Saturday. Our conclusion, Mary goes to the movies. Is the hypothesis true? And what can we conclude? Yes, our hypothesis is true. So therefore, Mary goes to the movies. That's what we can conclude based on the law of detachment. When it rains, I use an umbrella. It is raining. What can you conclude? Probably that you'll use an umbrella. If I wear garlic, a vampire will not attack me. I am wearing garlic. Therefore, a vampire will not attack. If the accused suspect has a valid alibi, then the police will not hold him. The crime occurred at 9:32 a.m. The suspect's place of business confirms that he was working with 22 other people from 7 a.m. to 4 p.m. on the same day. What's the conclusion? Right? The conclusion is the police will not hold the suspect. We also have a law of syllogism. If P then Q is true, if Q then R is true, therefore P then R is also true. This is similar to that idea of the transitive property. If A is less than B and B is less than C, therefore A is less than C. It's like 3-part statements that are linked together. If P then Q and Q then R are true statements, then P then R will be a true statement. If Rick takes chemistry this year, then Jesse will be Rick's lab partner. If Rick takes chemistry this year, that's our hypothesis, then Jesse will be Rick's lab partner. That's the Q. If Jesse is Rick's lab partner, okay, that was Q, then Rick will get an A in chemistry. That's statement R. See how in the notation we've got P then Q, Q then R, therefore P then R. So we've got our hypothesis labeled out. Number 1, Rick takes chemistry this year. Conclusion, Jesse will be Rick's lab partner. Hypothesis 2, Jesse is Rick's lab partner. Conclusion, Rick will get an A in chemistry. So what's the whole conclusion of the whole entire statement? Rick will get an A in chemistry. If we're applying the law of syllogism, let's take a look at our examples and see what you can conclude. Read them to yourselves, pause the video. When it rains, I use an umbrella. When I carry an umbrella, I don't get wet. So this is our P, then Q, Q, then R. When it rains, I don't get wet. If I wear garlic, a vampire will not attack me. So this is our hypothesis. This is our P. This is our Q. If a vampire will not attack me, that's our second hypothesis. This is our second conclusion. Oh, sorry, this should also be Q. If I wear garlic, I will not die. In a recreational basketball league, if a player receives 2 technical fouls in one game, then the player is ejected from the game. So there's a lot of information here. This kind of leads us into the hypothesis. This part is the conclusion. If a player is ejected from the game, hypothesis 2, then the player has to sit out the following game. So we can say that if a player receives 2 technical fouls in one game, then the player has to sit out the following game. Take a look at our examples and decide which form of deductive reasoning are we using, detachment or syllogism. If Dr. Klein is well rested for a surgical procedure, then she operates with precision. Dr. Klein did get plenty of sleep to prepare for today's operation. The conclusion, she operates with precision. Okay, so we just have an if and the hypothesis and the conclusion. Then we have a clarifying statement to prove that our hypothesis was true. And so we're using detachment to come up with the conclusion. Second one, if we don't make any stops, then we'll make it to the stadium by 12:30. If we make it to the stadium by that time, then we should be in time for kickoff. This is using syllogism. Our conclusion, if we don't make any stops, then we should see the game by time kickoff occurs. Number 3, even when firefighters follow all relevant safety procedures, if they enter a burning building, then there's significant danger involved. A group of firefighters entered a burning warehouse to look for people. This again is detachment. We have an if-then statement, and then we say the hypothesis was true. So therefore we can conclude with detachment. The store manager knows that if tomorrow's sale is not advertised in the newspaper, then the store will lose money. If the newspaper does not receive the order for the advertisement soon enough, then they will not be able to put it in tomorrow's newspaper. This is also syllogism. If the newspaper does not receive the advertisement order, then the store will lose money. You can use inductive and deductive reasoning together. We use inductive reasoning to form conjectures. We use deductive reasoning to logically prove the conjecture. What conclusion can you make about the product of an even integer and any other integer? By definition, an even number is divisible by 2. So we're going to use induction to form a conjecture. The product of an even number and any other integer is even. That's what we can conclude. When we use deduction to prove it, any number times 2 is even. If we let this rule represent an even number times any other number, therefore 2n times m is even because it is a number times 2. You have some examples here to take a look at. It says use deductive reasoning along with the laws of logic to write statements that follow. Indicate whether you use law of detachment or syllogism. And then you have 3 more to look at where you're deciding whether it's inductive or deductive reasoning. Pause the video, try it for yourself. If you park a car on a hill, then you should set the parking brake. You parked the car facing down a steep grade on a busy street. Conclusion, you need to set the parking brake. That's using detachment. If Cedric plays in a big game, then he gets nervous. If Cedric gets nervous, then he performs well. This is using syllogism. If Cedric plays in a big game, then he performs well. If an object has a greater volume than an equivalent mass of water, then the object will float in water. A ball has 3 times the volume of an equivalent mass of water. Therefore, we can conclude with detachment, the ball will float in water. Letter D, you diet for 3 weeks and lose 3 pounds. You can conclude that you can lose 20 more pounds in the next 20 weeks. Are we observing a pattern or is there a specific rule to this? This one's using a pattern that you observed, and that is inductive. It is the last day of the month and you want to buy a new jacket. Because you always run out of money by the end of the month, you conclude there is not enough money in your checking account for the jacket. This also is an observation, so we're using inductive reasoning. You use the rise of 8.1 and the run of 2.7 between 2 points on a line in the coordinate plane to conclude that the slope of the line is 3. This is using deductive reasoning. We have a rule that tells us how to calculate slope. So we're using the rule to come up with the conclusion.